All right, my name is Alice Boxhall. I'm a developer on the Chrome accessibility team. I have a bit of a cold, so I'm sorry if I'm a little hoarse here. That's cool. I didn't need to use my slides. All right. So I'll get into the guts of my talk in a second, but I just really like this definition of accessibility that you can find on good old Wikipedia. Accessibility is the degree to which a product, device, service, or environment is available to as many people as possible. And what I like about this is it doesn't make any reference to ability or disability. It includes people who are in a hurry. It includes people who are using a mobile device. It includes people who find small click targets really, really irritating. And to make it more explicit, I think that accessibility actually implies multi-device because you're making your product accessible to people in a wide variety of situations and from a wide variety of backgrounds. So today I'm going to talk about what inaccessibility looks like, so the types of patterns and things that are going to make your site inaccessible to various groups of people. I'm going to introduce screen readers. So for anyone who's never experienced a screen reader, I'm going to give a demo and explain how you can try out a screen reader yourself. I'll talk about what you can do to improve the accessibility of your site, how to assess the accessibility of your site, and then I'll have some links at the end for more information. All right, so what does inaccessibility look like? What constitutes inaccessibility? Well, here's a good example. Anyone seen this on their mobile device or even their computer? Yeah, it sucks, right? So this is what it's like when you cannot access something. So different users are going to require different things, obviously. So we have a bunch of different groups that we need to consider. Low vision, hearing impaired or deaf. Low motor ability, so this is someone, it can range from like having a tremor or having poor motor control right through to having no use of your hands at all. Screen reader or braille display user, so this could, I'll get more into that later. And voice control user, so this is the extreme end of lack of motor ability. And in almost all cases, accommodating these needs improves the experience for everybody. So who are the users that we're addressing here? So 9.2% of the adult population of the US, more in developing countries, have some vision trouble. So the way that you address this is very simple. Avoid low contrast text, because really, who likes reading low contrast text anyway? Avoid relying on color alone for communication. Make sure that the text is resizable, and as we saw in the mobile talk earlier, that's really useful anyway. Provide text alternatives for visual media. And again, this is really useful if, say, you don't want to watch a video to get the only documentation for that dev tool you'd really like to use. So 36.4 million adults in the US have at least one complex activity limitation. So this is motor control. This type of person may not be able to use a mouse, for example, or may have like significant trouble accessing small click targets. So provide large click targets, label your radio buttons. If I need to use one more form where the radio buttons aren't labeled and I have to click on that tiny, tiny circle, I may actually flip my table. Ensure your site can be used with the keyboard only. And this is something that I'm going to return to time and time again, because this will actually get you a really long way to making your site accessible for the broadest range of users. So screen reader and braille users are a much smaller number. From the point of view of web author, you guys, these groups are largely interchangeable, even though the way they access the page is going to be slightly different. Especially in the case of screen reader users, they may or may not actually be blind. They may have another impairment, such as dyslexia or learning disability. They may not be able to read. They may not be able to read the target language. They may be temporarily unable to read, such as like recovering from laser surgery, such as getting motion sick, that kind of thing. But by and large, the thing to remember with these users is without assistive technology, they're not going to be able to access the site at all. So this is the flash situation. All right, so screen readers. The way that a user with a screen reader is going to be interacting with the device, the screen reader or braille display is going to translate the interface of a site into text or speech. So in this case, we can imagine the interface has like a cancel button and an OK button. It's going to read out cancel button. The user is going to then hit a keyboard shortcut. And so with desktop screen readers, there are literally hundreds of keyboard shortcuts to make navigating really, really efficient. So they're going to go to the next control, it reads out OK button, then they hit another keyboard shortcut to send a click command. So instead of using the mouse, they're going to be using interacting via the screen reader. And then it's going to tell them that the button's been clicked. All right, so this is a demo of ChromeVox, which is a screen reader for Chrome and Chrome OS. It's built into Chrome OS, and I'll get to how to use it in a minute, but I'll just show you this first.
Home, list item. Sessions, link list item. Schedule, link visited list item. Clicked. Chrome Dev Summit 2013 navigation list with 3 items. Find in page. Enter. Multi-device accessibility link visited. Press enter to accept the exited. Find and pay. Chrome Dev Summit 2013 tab.
All right. So that was just me going through the Chrome Dev Summit site earlier with ChromeVox and finding my own session. Ugh. All right. So ChromeVox is built specifically for the web. It's built in on Chrome OS. You can activate it at any time on Chrome OS. And the really nice feature of it is that it's really easy to use for sighted users. A lot of screen readers that are dedicated for use by blind people don't have any kind of visual feedback. They're really difficult to learn the keyboard shortcuts for. You really need a lot of training. But ChromeVox can be picked up by a beginner in about a minute. All right, so my estimate is 30 seconds. It's probably a bit of a low wall. So as I said, keyboard shortcuts really drive screen readers. So we have a set of modifier keys we refer to as CBox. You can configure it. It defaults to Controller on Windows and Linux, Control Command on OS X, and Search Shift on Chrome OS. And in Chrome OS, you can turn it on at any time or turn it off with Control-Alt-Z. And ChromeVox AA will temporarily turn the ChromeVox feedback on or off if you have the extension installed in Chrome. Okay, so the way you actually use it, this is the way I will test things for accessibility as an extremely novice screen reader user. So use the ChromeVox keys and up and down to navigate through the page. So this is what I was doing in the demo a minute ago. ChromeVox space will force a click, so that this is how you click things when you don't have a mouse. Control by itself will make ChromeVox stop talking. And if anyone's curious what the search command I use is actually ChromeVox /. So on mobile devices, the story's a little bit different. Obviously, you're not going to have a keyboard. You're not going to have all these hundreds of keyboard shortcuts. But what you do have is a touch screen. So what they will do is use their finger to touch the screen and explore. Okay, explore the screen, and it will read out whatever they have touched. So in this case, we can imagine a user exploring the same interface. I really don't know what that sound is, sorry. Exploring the interface, finding a button, an OK button, and a cancel button. And this time, they've clicked the cancel button. So TalkBack is built in on all Android devices. You can turn it on from the accessibility settings if you want to try it out. So then you'll get a short tutorial on how to use the touch exploration feature like I was just talking about. So yeah, and in this case, double tapping will send, I think it's actually a click event, but it may as well be a touch event. And that'll allow the user to actually interact with things. On Android, you also have BrailleBack. This needs to be installed from the Play Store, but that will allow the Android device to pair with a Braille device. So what I've shown here is looking at the Chrome Dev Summit site using BrailleBack and with the on-screen Braille display to simulate what the Braille device will display. So you can see that it's pretty similar to the spoken feedback, except it will have all these abbreviations so that it can fit more information into a shorter space. All right, so what can you actually do to improve the accessibility of your site? Start off with the design. designed with diverse users in mind. So when you're looking at how to create your interactions, think about how a keyboard-only user would interact with your app. Don't assume that someone's going to be able to perform a hover interaction. And in fact, someone on a phone is probably not going to be able to perform a hover interaction either. How is a screen reader user going to interact with your site? So this means you need to think about what the text alternative, what the label is for everything. What's going to be read out when you are focused on a particular element? Is it just going to say div? Do you have images without all text? That kind of thing. And finally, how adaptable is your interface? If something is viewed via some kind of assistive device or viewed maybe by a text-only device, is it going to work or is it just going to fail horribly? So again, ensure that you have a good keyboard-only user experience. And what does this actually look like? Firstly, I shouldn't need to say this, but use standard widgets wherever possible. They come with built-in keyboard handling. So the Polymer talk yesterday went a bit into what you get for free with standard elements. User extend good custom elements with built-in keyboard controls. So when you can't use standard widgets or you want something that looks a bit different or behaves a bit differently, use good custom elements or write your own good custom elements with keyboard handling. So I'll get into what you need to do and to roll it yourself in a minute. All right, so if you're writing your own elements, whether you're using custom elements or whether you're just writing something from scratch, use tab index. That'll make things focusable. So if you have something which is a click target but isn't focusable, screen reader may actually have difficulties using it. Plus someone who's keyboard only will never be able to use it. I assume you all know how to use tab index, so I won't get into that. And handle keyboard events wherever you handle click or touch events. And if you want to know which keys to listen for, follow established user experience patterns for the platform that you're targeting. All right, this is something we may not necessarily think of, but is actually really irritating if you're trying to use an app keyboard only. Manage focus. So make sure that focus is in a sensible order with the tab index property. Make focus visible. So don't make your user find the focused element. So what does that game look like? It looks like this. I'm sorry to pick on Gmail. It's just that I use Gmail all the time and this really bugs me. Where's the focus here? You can see it if you really squint. It's actually right there. If you're showing a pop-up or a modal dialog and so on, move focus within the pop-up when you open it, so call focus from JavaScript, and move focus back to the element that triggered the pop-up on close. So I've clicked my focused element, or I pressed enter, and it showed a pop-up. So that's good, it had keyboard handling. Now where's the focus? It is actually in the pop-up, so that's cool. However, now when I close the pop-up, it goes to a random location in Gmail that I haven't actually figured out what the logic is yet. Okay. Next step, express the semantics of your interface. So as I keep saying, use standard widgets wherever possible because they're going to have the semantics built in. Or use well-written custom elements which are handling this for you. And again, if you're writing your own custom elements or you're writing things from scratch, use ARIA to express the semantics. All right, so this is a non-semantic interface. It's a div that has an onClick event, onClick listener. This is much better. It's a button. It still has an onClick listener, but it's going to actually have a tab index now. It's going to respond to keyboard events. And we have a custom element, sort of, that we've given an ARIA role. So that's now going to also be presented to a screen reader as a button. But that's not really the whole story. You still need to make it focusable and handle key events. So what's ARIA, this ARIA thing that I keep talking about? It stands for Accessible Rich Internet Applications. It's a W3C standard, and it allows you to express role states and properties for elements via HTML attributes. So we saw this role attribute, that's an ARIA attribute. So what that does, the reason I keep going on about semantics is that screen readers are all about semantics. It's going to view a modified version of the DOM that just tells it what the role and what the text is for each element. It's not interested in images. It's not interested in layout. And so what we see here is we've applied a role to this div and an ARIA label, which is an ARIA property. And that gets rendered to the screen reader as an actual button and allows the user to interact with this as if it was an actual button. OK. Thanks, Presently. Here we have a native button. And as we saw in the Polymer talk yesterday, this comes out looking like a button. And it comes out interact with a JavaScript DOM object, which allows you to access all the attributes you would expect for a button. It also comes out with an accessibility tree, which is mangled because reasons, that tells the screen reader that there's a button, and it has a press state, an on-press state, and so on. For custom elements, you need to do a little more work. So in this case, the custom element author has made it so that the custom element will write these ARIA role and attribute when the custom element is rendered to the page. So then we end up with a similar situation as we do for native elements, where we have a visual rendering, we have a DOM object that lets us access the attributes that we want and interact with them and get a good developer experience, but we also have an accessibility tree, which makes sense to a screen reader or Braille display user. OK, so how can you actually assess the accessibility of your site? Firstly, try it without a mouse, try it without a trackpad. I saw this great tweet from someone saying, the trackpad on my MacBook Air broke and I'm on a plane. To all site developers everywhere, please fix your accessibility. Try out a screen reader. The way you use a screen reader will not be the same as the way an experienced screen reader user uses it, but it will give you an idea of what things are labeled, what things are accessible via the screen reader, when focus has gone horribly wrong, that kind of thing. It's worth just trying it out. And you can also do automated testing. So there's this extension for Chrome called Accessibility Developer Tools. And it's also a JavaScript library, so you can use it in your continuous testing. And I'll give you a demonstration of that. All right. So it's comes up in the Audits tab. Yep, comes up in the Audits tab of the developer tools. So it just comes up here. I've run it already on this page, obviously. And it's come up with a couple of, well, many errors for this page. A couple I'd like to highlight. So we have this here, it says, it's unfortunately cropped by the page, but it says these elements are focusable, but either invisible or obscured by another element. So what's happened here is we have focusable elements that are behind this modal dialog, which for a screen reader user are going to come up as completely visible, even though to a sighted user, they're obviously inaccessible. It's going to be a really confusing experience. And what we want to do is make sure that everything that is hidden behind this dialog has an ARIA hidden attribute, which will hide it from a screen reader. You possibly also want to set the tab index to -1 to make sure that it's not part of the tab order. And then here we have it says text elements should have a reasonable contrast ratio. So I was talking earlier about users with low vision, or even just anyone using a mobile device in bright sunlight. Low contrast text is a real pain. And so I'll just demonstrate a neat feature that it has, which is that I can look at this in the Elements panel, and it'll actually come up with suggestions for colors I could use instead. So yeah, it's slightly darker and much darker. And finally, so here, one thing that's always bugged me about using ARIA is that when you write incorrect HTML, the DevTools is going to tell you, and it's going to come up as an error. When you write incorrect ARIA, you just sort of you really have no feedback until you try using it with a screen reader and discover that it doesn't work. So here we have a progress bar, and I'll show you what's actually happened. So I've tried to set the value to 80%, but it turns out ARIA value now takes a number instead of a string. So when I try and view that with Chromebox, actually no, I can't do that. Anyway, when I try and view that with Chromebox, it actually says progress, not a number %, which is really embarrassing. So I can actually fix that. And now it's telling me that it's correct. All right, so just to sum up, improving accessibility will almost always improve the experience for everyone. Even when you're looking at screen reader accessibility, what you're doing is expressing your interface more semantically, which will improve the maintainability and testability of your code. There are testing tools that actually look at the accessibility tree in order to create interaction tests. Keep diverse users in mind at all stages of development. So when you're designing, when you're building your interface, when you're testing, make sure that you're testing the interactions that anyone would use. Have a good keyboard-only story. If you do one thing, please do that. Express your interface semantically as well as visually. I think I've covered that. Use automated and manual accessibility testing. So I demonstrated a bit of how to do both of those. And finally, listen to your users. If you have users filing accessibility bugs, follow up with them, figure out what's going wrong. And finally, we have some links. So a bunch of screen readers that you can try. I demonstrated Chromebox. There's also a screen reader built into, and I showed you some screenshots of TalkBack. There are screen readers built into every Mac desktop and iOS device, which is VoiceOver, so you can use that as well. And a few other ones. So these are all free. A bunch of them are open source. And so as much as we were ragging on the web content accessibility guidelines, they're actually worth a read. The WARAS spec is there. The Accessibility Developer Tools extension and library are there. You can also search for them on Google. They're pretty high up in the search results. And that's all I have. Thanks a lot.